All right, should be good.
So one thing I noticed is we actually have to use the normal probability applet,
Yeah,
like to check things, and that is tripping me out because we haven't used it.
in a while.
Yes. And I'm not, my brain is not,
Triggering which
just
way
like on that one
like
question
that.
that you guys were like, we can't figure it out.
Oh, I know. Well,
That was where I was like, wait, what? We're going to what now?
yeah, well, that was tough because yeah, I didn't even think to do that until I'm like, oh wait, nothing else is working here. We've done all the equations.
Yeah,
Of course, it's something simple.
yeah.
But anyway,
It
I
would
can
be.
right. I can read the first one. It says the symbol for the true population proportion is which of the following?
Wait, I thought we were on quiz on 17.
Huh?
Aren't we on lesson 17?
Yeah, quiz 17.
Yeah.
What's your number one say?
Oh, I went to the wrong quiz.
Uh,
Just kidding. Hold on.
okay, I was like, wait, what?
No, I clicked the homework one.
Oh,
So
okay.
my screen, I have it on my half screen. So
Uh,
when I go to click on something, it has to like focus. So it probably dropped it down because I was like, wait a minute, I swear I clicked on the group meeting.
you're good. I'm
Just
like, I have it
maybe I
right.
didn't. Whatever. Yeah, okay. So the symbol for sorry.
There you go.
So P is the true proportion, correct?
Yep. Yep. A
Okay.
lot of
And
fun.
P half is just like the representation.
Yeah.
Okay.
And question two for the next two questions, suppose n equals 100, p equals 0.25, and p hat equals 0.09. The requirements for constructing a confidence interval are satisfied. True or false?
So that's the N times P, right?
Going back to my notes here. I believe so, but let me just.
And it's the N and then N times 1 minus P.
We need the z's, what we're missing out of this one.
Why do we need the Z?
Is that in the equation? And the reading is confidence intervals. Then the equation is like parentheses p hat minus z times.
Oh,
You see it?
oh, okay. So, okay. This is where I get confused. I cannot tell. Sorry.
No, you're
I
good.
go to the toolbox.
Yeah.
This is where I struggle to determine the difference
Mhm.
of the hypothesis versus the confidence interval. I feel like I'm missing all the time.
Yeah, I think it's definitely like repetition. Like what I try to do is like, I mean, I don't test well, so it doesn't help me, but I try to just look at equations that are of like there is enough evidence, like when we had those questions where the evidence is sufficient or insufficient. And then I try to test myself that way just because the words get kind of tricky and like some of the equations are super similar. You know what I mean?
Yeah.
But so for question two, it's false because we don't have enough requirements in there.
Okay. Can we find Z though?
Um, yes, it was in lesson 16. I forget the equation, but I believe there's an equation to find Z.
Okay. I was gonna
Because it
say if
gives
we can
it-
find Z, then we are able to do it.
Yeah, well, I think because like the given information didn't include it.
Oh, and it gave you already finished it, so that's true.
Yeah, I've already taken.
Okay.
You're good.
The
Um,
requirements for conducting a hypothesis test are satisfied though.
what do you think?
Yes, true.
Yep, true. Okay. And for the next one, question four, use the following information for the next four questions. A study of first degree murder trials was conducted in another state. A random sample of 60 people on trial for first degree murder was taken. On these 45, the defendants were found guilty. Of these 45, the defendants were found guilty. Find P hat the point estimate of the proportion of the first degree murder defendants who are found guilty in the state.
This is where I'm like, why can't I just find a percentage? I know that sounds really, really simplified, but in my brain, I'm like,
So actually, hold on real quick. I have to tell my son.
you're good. Go ahead. Julie, turn it down, please. Ayla! Come here.
Later, son. So actually, for this one, my brain also went to that, like find a percentage.
Yeah.
Of course, we don't have percentage for these answers here. So I actually did 45 over 60, and I got 0.75 because it's 75%. Oh,
Right.
yeah, hold on.
You're good.
Holy smokes. All right, he's gone. He was putting like his mouth under the door. That way it like was louder.
I have gone to the bathroom on several occasions where my kids have done that, or even like shove things underneath the door. And I
Yeah.
learned that if I just leave the door open when I'm going to the bathroom, most of
It
them
doesn't
actually,
happen.
they leave me alone.
Yeah.
Like the door's open, mom's going to the bathroom at school, whatever, and it's fine. But if I have the door closed, like I have one of my doors has like marks where my kid hit it because he was so mad because I closed the door.
Yeah, he's beating the door. No, my son's the same way. Like my wife went to a play in Utah last year. And my daughter was maybe 6 months old. I can't remember, but anyway, I had to do a Zoom meeting on a Saturday, and my wife was gone. And I wouldn't say the word angels, but there was not much happening. You know what I mean?
Yes,
But
that makes it tough.
yeah, it's
All right.
interesting. But anyway, the next question. Create a 95% confidence interval for the true population. For the
What
true.
was number 4 though? Sorry.
Oh no,
Yeah.
you're good. So no, so
I
the way
didn't do
you
number
thought,
4.
like the way like your brain worked, to find a percentage was actually correct.
Okay.
It was 45 over 60, which is 0.75.
Okay, well, that's what I thought. And then I was like, maybe I'm not doing it right.
Yeah, no, I was the same way, and it worked. So
Okay.
at least that's how I set it up, and the answer was correct. I mean, that doesn't mean.
Well, I was gonna say I didn't see anything that talked about, you know what I mean? So I was like, maybe I'm not doing it right.
Yeah, no, you're good.
Okay. 95% confidence interval. This is where I feel like no matter how many times I repeat it, I don't know still.
Let me see if I can.
This is, I understand it's p hat plus or minus z over the square root of all of the things, but in my brain, I struggle.
Yeah, now you're good. So let me get the equation. We got to find the z-score for it because we do have to fill out that thing.
Yes.
Actually, I think you can also use the toolbox. Hold on, let me get back. Let me see
I
if
think so too. And that's where I was kind of headed to see if we can just type it in.
Yeah.
Okay, we can, I think.
Yes, we got X, N, and then
X would be 45,
Yep.
N is 60. P hat, it already gave us P hat at 0.75.
Mm-hmm.
A 95% confidence interval. Okay, it's already there.
What'd you get?
We want it for guilty.
So you want
The
the
lower bound is
lower bound.
0.64 and the upper bound is 0.86.
Yep, correct. And I can read those to you if you need me to when you put them in.
I got it.
Sweet.
Thanks. Okay. If you increase the sample size from 60 to 80, what do you expect to happen with the width of the confidence interval?
So if you like make it taller, what's gonna happen to the width? That's what it's saying.
Oh yeah, doesn't it make it narrower?
Yeah, so it'll decrease.
Yes.
Okay. And for question 8, to conduct the hypothesis test for one proportion, 2 requirements must be met. Suppose P equals 1/2. What is the smallest N can be for both requirements to still be met? And that's the same as the other night where the answer was 40. This one's 20.
Right.
You just multiply.
By 2, yeah.
Yeah.
Because I was gonna say you have to put it over and then you would.
Yeah. So the answer is
Yeah.
20. Yeah.
Okay, to conduct a hypothesis test for one proportion, two requirements must be met. Suppose P is 1/10, 1/10, what's the smallest N can be, and both requirements still be met. It would be 100. Correct? Okay. Does it say, because it has to have like 10 is the magic number here,
Yeah.
where, yeah. Okay.
All right. For question 10, use a. We're gonna read it. Sorry.
I was going to, but I had a, sorry.
No, you get. I can read if you want. That we don't have to talk as much.
Sure.
Okay. Use the following information for the next 6 questions. For the water quality study in the reading, about 60% of the macro intervrate water quality indicators have historically been associated with good health. The researchers suspect that water quality in the area has decreased. They conduct a hypothesis test using a level significance of sigma equals 0.05 with the following hypothesis. P equals 0.6, P is less than 0.6. They collect new data, and this time N equals 80 and X equals 38. Indicate good health. The conditions for conducting a hypothesis test are satisfied. True or false?
Oh, I'm so sorry.
No, you're totally
I
fine.
actually did really good until about 10 minutes ago.
Oh, good. Of course.
Yeah, I was like, no, I have to start off. No.
How it works.
I'm gonna say they are met. Wait,
So you think true?
yes, that's true.
It's true. Yep. Correct. And
Well, I did it in my head, and then my head was foggy, and it's like, no, that's wrong. And I'm like, no, is it?
no, you're good. Yep, you're right. It's true. And question 11, what is p hat? So the way you get p hat is just x over n.
Right.
So it's 0.475.
Okay.
And we should now be able to put all this in there and get the other answers.
Working on it. I closed my. There we go.
You're good.
A statistic would be the negative 2.282.
Yep.
P-value is 0.011. And the decision for the test is to. We would reject.
Yep. We'll reject it. Exactly.
Which of the following best summarizes the conclusion for this test? Do we say there is sufficient evidence to conclude the water quality in the area has decreased?
Yep. So the last one.
Okay.
And
On 3 brands of batteries are under study. It is suspected the lives of 3 brands are different. An experiment is conducted to test the hypothesis. 5 randomly selected batteries of each brand are selected. The time in hours until the battery is effectively dead. Power out. Girls, please. The power outdraw or output drops below a specific level is measured for each battery. What type of analysis is best suited for this study? Well, if we're gonna do each brand, wouldn't it be an ANOVA?
yep, exactly.
Okay, it says 3 brands, so.
Yep.
Thanks, cool. Yay, 15 out of 15.
Yeah. I'll go ahead and stop
Funny.
recording.